Would you really like me to take my time? We don't have to fight. Just take it step by step. I can feel it in your eyes. Think that it's tell me lies. Would you that kind of shade? And they keep between your legs. Thinking of love and what it is you. You don't have to run. You the simple time. That you bring. So, you don't. Uh,
Oh, this is sneakers. So I got it from Ninja Market last month.
oh, nice. What is it made of?
I have no idea. I think they just like crocheted it like on a metal wire. It's actually really good. I don't know.
You don't even know enough. We can make it right. You gotta really try.
They're going okay. I just a lot of work. Also, like friend group are on the it's probably going on right now. It's so awesome. That's what I was saying. Like, oh my god.
Make things hard for no reason.
I never this would break down. So I'm going to like stay like at home all day. Let me see what will be some.
We don't have to rush.
Data is gold. The hackers. McAfee helps keep you safe with AI-powered spam detection, secure VPN, and award-winning antivirus. Plans start at $39.99 for the first year. Visit McAfee.com/online protection. Terms apply.
Just another. Used to be forgotten. I took a chance with my heart. Taking out from
You good? No, you're good.
never find your love. Never find your heart. Never find your love. I better find your heart. I better find your heart. Oh, there is I'm more than just a number. So every single summer, you don't want to let you remember. I never found your love.
Oh, yeah, you could turn it. Let's set it up. Sure. We're more just a collaborator, I think the initiative of that's coming up. Actually, the guy that, oh, really? Yeah. Yeah, I really, details, they just said, okay.
Yeah, but you don't
I just said, you know what?
in case you've been missing, I better find your love. I better find your heart. I better find your love. I better find your heart. I better find your love. I better find your I never wanted to tell that you love me. I never want me to love you when I'm alone. I never wanted to be where you would know me. Was the slipping and this and it will be. You took a look at me, niggas ain't not about me. I tried to give you my heart, but girl, you don't know. I tried to show you exactly what the way won't go. I was like, baby, somebody make me some time, you know. Somebody to love me, give me some time to fall. Wait,
Hard enough to
it's like
make
it's
it.
close.
Yeah, well, I mean, it's not sure. Like, it's just like. No, or like you can push back, but, yeah. We.
Jealousy, why I should have listened to this today was telling me I'm true as thinking the way you was the side of me. Now I'm part of this if you wish to what I don't think that that's a young dog, but I'm something, I'm not something still. And it should be my something. I'll lay it over where it is you can get it. I know I tried to better. Oh man, we have fun then. God is to better. Yeah.
It's right out of my bones. I don't know either. I'm like studying for linear algebra, I'm like 2 questions, 3 questions, but you know, slow, take my time, and it's like already like 2 hours later. Yeah, I'm still just saying, like, I gotta move on.
Everybody in the Christianity in the face. The whole thing. So, no, these white ladies watching CNN covering this. They read their headlines and they all started clapping. The wrong just sort of basket at the bus.
So you're saying that's right. Like 3 days.
Thought it was down some the police, they don't let them know for niggas in the.
Wait, we're only for like 3 days and then everything else is like, it's like a week cruise or something. Okay, well, since it's 5, we already got some people on here, so. Hello. People on Zoom, can you hear me? You just say whatever in the chat. Okay, well, really quick, if you guys haven't signed in, please do. I need to do that too. It's really important for us to keep track. Welcome. What's up? How you doing? Oh wait, you want to start off actually? Like, I haven't even said anything yet. Do you want me to show that slide? Like what you texted me? Oh wait, I forgot I'm not logged in. You could, do you know how to set it up from here?
On that little console, you should press that.
Oh. Those, oh, there you go. But I don't think the people on the Zoom can't see it, but it's okay. Actually, wait, I can like hold it up. Like, so they can't be right here.
Yeah,
Here.
I guess that works.
All right. Actually, I don't know. I don't think read it, but you just talk
I'll share it on
yeah,
the.
they can see it. Yeah,
I'll share it on the Discord afterwards. For those of you here, so, but I'm the president of Software Engineering Club. Software Engineering Club will be hosting our first LeetCode tournament, which is why we decided to partner with LeetGator. It's one of the clubs we have on screen there. So we're going to be helping out with LeetGator's next couple workshops. If you guys are interested in LeetCode and the prizes that we have available, we're still deciding on like the prize bracket specifically, but overall there's $1,000 in prizes. There's free food, free merch. So it's going to be that April 12th, that Saturday. So make sure to scan that QR code. We're going to probably repost it on the Discord for those of you who don't have the chance right now. But if you guys have any questions, definitely feel free to like stop and ask me.
Tell them your name.
My name's Sora, by the way. On the interest form, there's a link to our Discord where you can contact me as well for those of you on the Zoom. I think that should be good.
Okay, yeah. Yeah, as you said, if you guys have any questions, be sure to ask. Yeah, it's fine. Sure. Yeah, no worries. We normally go for like about an hour. It just depends, like, you know, how fast we go through. You know, just like depending on the topic. Well, we're doing stacks this week, but okay. Hello everyone. So thank you, thank you, thank you, Software Engineering Club. So yeah, Zoom can see. Okay, so yeah, if you haven't signed in, please sign in. And so today's plan, we're gonna go over intro to stacks in Python, and we're gonna practice. So these slides I've already have spoken on, but I just think it's important for anyone that's new. At least I know in person, everyone here has heard me say this, but I'll just open this up for like a general open forum about anything with interview process or really just anything. So if you guys have any questions in the room, possibly about literally anything, we could talk about it, we could discuss, and if people on Zoom have any questions, you could let me know, or if you want me to, the people on Zoom, if you want me to read through and explain what I mean by this, then please let me know, because people already heard it. I'll just move on. So in the room, anyone got anything? Any questions at all? Cameron? No, no, no. Is this like yes or like okay, okay. All right. Anyone on Zoom? Let me see. Can I even see the chat? Does this thing work? Oh, how to sign up? Oh, are you talking about the software engineering club? Oh wait, what time is it? Yeah. Yeah. Okay. Yeah. Yeah, sorry. Yeah, he didn't we forgot to send it to each other. So I was just holding his computer up. But yeah, he's gonna join the Zoom now and he could send you the link or it's also gonna be on Discord and we're gonna be posting it. So yeah. And if you have any questions, other questions, please let me know. Okay. So considering that we're all familiar with this, well, we're gonna talk about stacks. So I'll leave this to Adrian. The pen is working, so when you write.
Oh, cool. Okay, so let me test the phone real quick. I just like, how do I use the pen? Or should I just like,
I think it was just like pop up. It just like pops up on the side, like automatically. Let's see. Oh, clearly it's working. I don't know how I did it. Wait, sorry.
you're good.
Maybe this needs to be over here. Let's see. Do monitor like messes it up. I'm not really sure. Did you see it?
Yeah.
On this bar. Okay. We just need to go back and forth.
Okay. You're good.
Sorry about you guys.
Yep. So let me. Okay, so yeah, today we're gonna go over stacks. So we're just gonna start here. I think everyone should know what stacks are, but of course we're still gonna go over it because I'm sure that all of you are in Prog 2 or higher. I know like some people in the chat are Prog 2 and DSA. But yeah, just in case you guys don't know what a stack is, it's one of the most basic data structures. And the important thing is kind of like this representation is when we insert items, we also take out items from the top. They are taken out and placed in the same order. So for example, in this, it's just a pile of plates as like a kind of like a real life representation of a stack. But let's say you're putting like these plates, starting this one, all the way to the last one. You can't take out any of these plates without like destroying the whole thing, you know? You have to take out the top plate. And that's kind of like what the point of a stack is. So let me go over this slide first, actually. So a stack, it's represented kind of visually like this, where you're putting things in from the top and you have to take things out of the top. So going over how you add things to a stack, it's known as pushing. It's kind of the same as like, appending in Python or just like adding things to some sort of data structure. So you can see we place one, then we place two, then three. And then popping, that's how we remove things from a stack. That's always going to take in the item that was just put in. So you can see we can't even take out one and two. The only item we can take out is three, which was the one that just got placed. So this is known as LIFO, which is last in, first out. Does anyone have any question so far? Let me check the chat. Okay. So yeah, going over like why we even use a stack. The point of using a stack is we actually implement it just like an array, which everyone should know what an array is, or just a list. The only difference is that we're always popping from the end of the list. We're always removing things from the end of the list. And what this does is this actually reduces the time complexity of removals from big O of n to big O of 1, which saves time. And that's the whole point of a stack. It's when we want to use the fact that we only need to remove things from the end of the data structure. Because when we do that, we can make things faster. So going over the stack operations, we have them like right here. We have the first one, which is pushing. That's the same as like appending. Just adding things to the stack. And remember, again, it's always the top of the stack, which for an array, it's also known as the end of the list. Popping, same thing, but just removing. It's always from the end of the list. These two return booleans. It's just checking if the stack is empty or the stack is full. Basically just like existence of items or if it's reaching a max capacity. And we don't really use is full that much because, for example, in Python, you guys should know that arrays are dynamic. They don't have like a max size or anything. Where, for example, an array in C++ does have a max size. So in this like situation, this doesn't really matter. Same with vectors in C++. They're the same as arrays in Python where they change their size behind the scenes. And then peek, this is the same as viewing what is on the top of the stack. We can't view the other elements on the stack because remember, it's a stack. We only can work with the top element. So that includes both adding things, removing things, but also looking at the item. So what peek does is it gives you the value at the top of the stack without removing it. Does anyone have any questions before we keep going? Okay. So how can we use these in Python syntax? So we wrote kind of the conversion from the basic command to Python. So again, this isn't a specific data structure. Like for example, in Python, you don't really write the word stack. You just create a list. That's how we're gonna make our stack. And the way we make it a stack is by using pop as a removal. You don't want to be removing things from the middle or start of the list. Because that's just a list. That's not the point of a stack. The point is, well, we're only popping from the end to improve the time complexity. So how are we going to use these? And we're going to see these inside of our solution today. So it's definitely important to understand how these all work. So if we want to push or add things, that's going to be the .append function. Because remember, we can only append things from the front. So you don't want to be using something like insert inside a stack. Because remember, pushing, popping, and peeking in stacks, there's O of 1. Where pushing and popping in just a regular array would be big O of n. So moving on to pop, remember pop actually in Python is exactly the same. It's also just .pop, and this will remove the last item in the list. And then we have is empty and is full. For is empty, you can use the word itself. So for example, if we have an array called stack, we can use that kind of as a Boolean. So if I'm saying if not stack as a conditional, if not stack is true, that's saying that the stack is empty. If we say if stack, that means the stack has an item in it. And we're going to use this in our solutions today. So that's important to understand that we can use the name of our array to say if there is an item inside of it. For is full, again, this doesn't really apply because Python's arrays or lists are dynamic and don't have a max size. So don't really worry about this one. And then last important part is peeking. If you want to peek in a stack, that's just using the bracket notation and using -1. Because if you don't remember, you can use negative indices in Python, and -1 is always going to be the last item in the stack or the array, regardless of how big the size is. So we're going to be using peek, is empty, popping, and pushing all in our final solution. So does anyone have any questions before we get started with the question? Okay. So let's just go over the problem. So today we're going over valid parentheses, which is like one of the most like one of the first like stack questions you go over. And of course we're also going to go over the brute force solution, which doesn't use a stack, but let's just start going over the question. So given a string S, it's going to contain 6 different characters, potentially 6 different characters. It can contain these kinds of brackets. So we have open and closed versions of parentheses, square brackets, and curly braces. And that's all the string can contain. It can't contain anything else. So you're not going to see like letters or numbers or spaces or anything. And you want to determine by returning either a true or a false, as you can see from these examples, if this is a valid parentheses. And the input string is valid based on these 2 conditions. One is that all open brackets have to be closed, and it has to be closed by its same type of bracket. So for example, these 2 parentheses, of course, correspond with each other. Same with the curly braces, same with the square brackets. They have to be paired together. And then, oh, there's actually 3, I didn't see that. Anyways, so point number 2 is that it has to be closed in the correct order. So for example, it says open brackets must be closed in the correct order. What does that mean? So if I have, for example, it says in the correct order, let's say I have a parentheses here, and then I have a square bracket here. And let me like actually put these just to make it more clear. We have these 2 would close each other, right? And then these 2 would close each other also. But the problem is this is in the wrong order. This should be closing this, but remember, this is in the way. It always wants to close whatever is closest to it on the left. So these 2 would actually try and pair together, and that makes this whole thing invalid. Something that would work is this, which is the exact same thing, just rewritten in a different order. If we have it like this, of course, this is going to pair with this, and this is going to pair with this. And we start with the first closing parenthesis. We checked, find the first closing one. Can it be closed by the next open bracket? Let's see, do they match? Yes, they do match. So we can actually just pretend they're not there anymore. And then now we're kind of just, the string kind of just turns into this. And then we kind of just do the check again. Find the first closing bracket. Can it be closed by the first opening one or the kind of the last opening one? Because let's say I had one kind of like this, just a bunch of parentheses in a row and then a square bracket. This square bracket, it's not going to check any of these, right? It's going to check the very last opening parenthesis, which was this one. So in this situation, these 2 can close each other. And when the string becomes empty, that's how you know it was valid. Does this make sense to everyone? There's a lot of small things in this question to try and understand, and then they all like piece together at the end. So definitely a lot to take in. So let me delete all this. Okay, so let's go over these 3 examples. So the first one is going to be just parentheses. So just like this. Is it true or false? Like we said, the whole idea that we're doing here is we need to match parentheses together. A closing one needs to find an opening one. So let's check this. Does the closing one have an opening one? Yep. So this is good. So it's true. It's our most basic example. This one you can see right here. We have basically all the types of brackets. So we have curly brace, we have square, or we have parentheses, square brackets, and then curly braces. And then let's see. Remember, the whole idea of how we're going to check if something's valid is we want to start at the very start of this kind of lineup of characters and keep going until we find our first closing parenthesis, because we need to make sure that this closing parenthesis matches with an opening one to kind of disappear. So for example, we start over here, check, is this opening or closing? If it's opening, we just like leave it. And then we can see this one's closing. This one's closing. So now we need to start looking left and find its opening pair. So we know that these 2 match up. So we kind of just pretend they're not there anymore. Next up, square bracket, these 2 match. Next up, curly brace, these 2 match. So it was just the same thing. And remember, like, we know that our solution is valid if we can clear every parenthesis. And if we can clear every parenthesis, that basically just means, can we make S an empty string? That's important to understand later on, because remember, when I found a pair, I kind of just pretended it's not there anymore, right? Because they got closed, so that part is valid. And you kind of just keep removing valid parentheses until there's nothing left. An example where this is not true would be this one, where you can see it's opening parenthesis, then a closing square bracket. You can see that these 2 don't match with each other. So this is going to be, it's trying to find an open square bracket. There is none. It's not even that there is none, because for example, if I made this example, this is also invalid. So it's not the fact that there isn't a square bracket to close it with. It's the fact that the most left, like the closest thing to its left, it has to be matching. So we can see that because this parenthesis is in the way, when I try going left from this closing parenthesis, they can't match, so this whole thing's invalid. So, does anyone have any questions so far? Okay. So I'll do a couple more examples that aren't included on this slide, just so like we make sure we have a good idea of what we're doing here. So for example, if I have an input string that looks like this, is this valid or invalid? It's invalid because when you know that for a parenthesis to be valid, the open one needs to go first. So in this case, this will never be valid regardless of what it's on the right. The reason is the very first character was a closing bracket. So it doesn't matter if like these were valid in the front and like these all get canceled. If there's ever a time where there is a closing bracket and there's nothing on its left to cancel it, it can never be valid. So that's important to understand that we always need to have some opening bracket before we even see a closing bracket. So that's one important aspect to understand. One that I've already said a few times now is not only do we need to make sure that a closing bracket can match with an opening on the left, it also needs to be the correct one. So for example, another example is if it's like this is invalid because these don't match together. So there are two things to check for when we are appending a closing bracket. When we append a closing bracket, we need to check one, does the stack have an item? Because if the stack doesn't have an item, that means the closing bracket is the first thing in line. That means it can never be valid. So basically, just check if stack. The reason we do this is we need to check, is there an item there? And if so, now we can do the second check, where we want to check if the item to its left is going to be that opening brace. It has to be the one that matches with it. So those are the kind of the two things that we need to keep in mind as we keep going. But I'll leave that for now, and we're going to go over the brute force solution first. So let's just move on. So brute force approach is, what are we doing? Remember that we are, like I was saying before, we were kind of just checking if we can close every bracket. So once we close something, we kind of just remove it and pretend it's not there, right? And we know that it's a valid string, like I was saying before, if we can make the whole string empty. So the brute force approach would just be check over and over again if a pair of valid parentheses exists. So check if something like this is inside the string, or if this is inside the string, or curly braces are inside the string. Because if there are, we just pretend it's not there, we remove it, and we basically just keep doing that over and over again until one of two things happen. Until either one, there are no more to remove, and we can see that if the string is still holding characters, we know it's invalid. The other check is if the string was empty by the time we're done, then that means it was valid. So let me show what the brute force looks like. So it's very short, but it is pretty expensive. So we can see that it's just one while loop. It's while like these valid parentheses, which are parentheses, curly braces, or square brackets, if any of these exist inside of the string, you just want to replace it with an empty string. That's kind of like crossing it out, or like pretending it's not there anymore. And the final result is just returning a Boolean if the string is empty. If the string is empty, that means it was valid because you were able to cancel every single parentheses together. If the string wasn't empty, that means it looked something like this, or there are a few ways it could have looked. It could have looked something like this, where you can't close these. It could look something like this, where it's the wrong bracket matching. So if string is not empty by the time you're done, that means there is something that could not be crossed out, because the only things that can be crossed out are valid parentheses that look like this. So does this make sense to everyone? Does anyone have any questions so far? Okay. So going over this, we can do better. So does anyone have any ideas on the time and space that it would take for these? Yeah. It's definitely a bit harder to see. It's not like a standard kind of thing to analyze. So I don't blame anyone if you guys don't know. It's very like function specific. Yeah, it is.
Okay, that was probably.
Yeah, exactly. Exactly, that's correct. So for anyone that's in here, the time complexity would be big O of n squared. And the reason is replace is a big O of n operation, because think about it, you replace can't just like find something in constant time and remove it, right? Remember that looking for something in an array and deleting something in an array is big O of n. So that makes replacing something a big O of n solution. Also, the fact that like checking for this is big O of n. But anyways, remember you could like, if I have a string like this, so if I just have like a bunch of parentheses, like imagine I have like a million of these. If this is valid, like I'm replacing every single like thing and like cross out, and then while loop runs again, cross out, while loop runs again. And it just keeps going and going basically. So yeah, this is gonna be big O of n squared, as this is a big O of n operation and it can be up to n times. So does anyone have any ideas on what the space complexity would be? Yeah. I feel like I should have just made a slide to like make sure I'm correct, but I'm pretty sure it's O of one. I could be wrong. It's either big O of one or big O of n, but the way I'm looking at it right now, it makes me feel like it's big O of one because we're not using any data structure to hold anything. So yeah, again, the thing is we prioritize time complexity when we try and look for optimized solutions. So we can get this time complexity down to a big O of n solution, but it's going to take some memory to compensate for that. We're going to use big O of n memory. So does anyone have any ideas on like what can we do? Probably a big hint is the idea of this workshop. So yeah, we're going to use the fact that we have a stack, right? And this is kind of going to be our key idea of how we can run through this and make this more efficient. Because remember, right now, like replacing things and checking for things is big O of n. If we can get that down to big O of one, that would make this a big O of n solution. So I already talked about the main idea here, which is that we need to analyze the two cases we have. So what kind of parentheses can be added? We can either add open parentheses or closing parentheses. So that's kind of two kind of different if conditions in itself. We first check what is the first character in line. So remember, S is some given input string. So it's going to be some string. Let's say it looks like this, just this, and then brackets, and then let's just go for two more brackets. Actually, we'll make this invalid and put another bracket. So let's say that it looks something like this. Basically, we want to look through every single character, right? Because we have to check the whole string. So there are two conditions. One, it's either a closing parenthesis or it's an open parenthesis. So let's go over first if it's an open parenthesis. So let's say it's something like this. Or again, it's going to be something like this. It's just one of our three opening parentheses. If it's one of these, what do? All we do is we're going to add this to our stack. Because remember, we can have as many open parentheses as we want, right? We can have all of these as long as they're going to get closed in the future. But we can't say that about closing parentheses. If we start our stack with even one closing parenthesis, it's instantly invalid because this can never be closed. There's no open parenthesis on its left. So that's why whenever we are adding these open parentheses, it doesn't matter that it's open. There is no other condition. Just if we see an open one, we want to add to our stack. So we're going to push this to our stack. Does that make sense, everyone? Because these can potentially be closed in the future. So it's no big deal when we see an open parenthesis. The bigger issue is when we see a closing parenthesis. So the second condition, remember that when we're going through our stack or going through our string, we either see open parentheses, and if we see it, we're just going to push it to our stack. If we see a closing parenthesis, it's going to be a little different. So let's say we have our closing parentheses. We need to check for two different things. It's going to be either valid or invalid. So what makes something invalid? What can this be to make this invalid? There are two cases where seeing a closing parenthesis makes us return false if we know our string is invalid. We know that it's going to be invalid if the stack was empty, because if the stack is empty, that's like saying there is no open parenthesis to close this off. So just like in this example, here our stack, remember our stack is just an array, right? So just like this, if we have some opening parentheses in the lineup, then we know that a closing parenthesis can be fine. But if we are starting our stack with a closing parenthesis, we can instantly return false, as we know that it will never be valid. So if the stack doesn't not that it doesn't exist, but if not stack, if there is no item in the stack, then that means we're going to return false. Let me use the pen. So if not stack, then we're going to return false. Does that make sense to everyone? If we see a closing parenthesis and there's no opening to match because we know the stack's empty, then we return false. And there's actually another case where we can return false. Does anyone have any ideas on what's another case where if we see a closing parenthesis, we know if we can return false or not? There's only one more other case. One is if there's nothing in the stack. And does anyone have any ideas on what the other would be?
At the top of the stack, like an opening of a different type.
Exactly. Yeah, that's exactly correct. So, like was said, if we see here, for example, if our stack has this, right, we have three open regular parentheses. If we see a square bracket next, not only do we need to check if the stack exists, which the stack does exist, there are items in the stack. So this one is good. We did not return false here. But the next thing we have to do is we have to check the top of the stack. Remember, the top of the stack is the last item that was before the one we're about to add, right? So it's going to be this one, right? If it's not the same, this is not the same, this can never be valid. So that's our other case where we return false. So what is that? That's saying if the top of the stack, which remember in Python, we can use -1. So if stack -1, and what are we going to do to match this? Remember, we're pairing our closing and opening parentheses together because obviously the computer doesn't understand or doesn't have an easy way of knowing that this is the wrong bracket. So we need to give it a way to do that. Remember, we're kind of pairing our closing bracket to our opening bracket. We're saying if we have this, we want to check if the top of the stack is the opening version. So we need some kind of way to map these to each other. We want to have some way of saying, hey, if my character is a curly brace, I want to check if the top of the stack was the opening curly brace. Does anyone have any ideas on how we can kind of make this like pairing easy? How can we like find a way to pair these two together? This is kind of a little bit trickier, and it doesn't involve a stack, but does anyone have any ideas on how we can map these together? Exactly, yes, a dictionary. Because kind of the hint was mapping. When we're mapping things in key value pairs, so you can see if we're saying one thing wants to lead to another, that's kind of like a dictionary or a hash map. We're saying we want to check like these two are related. So what I'm saying here is when we are trying to add a closing bracket like this, we want to check if its opening one exists too. So using a hash map is a very easy way to kind of just pair these two together because there are 6 different characters, but in reality, there's only 3 pairs because when we see a closing bracket, we only want to see its opening version. Does that make sense to everyone? And we're gonna I'll go over that when we code this. But yeah, that's the other case. We want to check if this is equal to its open version. And the open version, that's going to be using our hash map, which again, I'll go over later. If it's not equal to this, if it's not equal to our open version of the parenthesis, then that's also false. Then we're also returning false. And then let's say that it was valid, right? There's one more case. So these 2 cases were things that instantly return false, things that instantly know that we can stop here. There's only one case where it's good, it's valid, and we can continue looping through everything. And that is not going to return true because remember, we can't return true after one iteration. We need to check the entire string, right? So the only thing that could make this valid is if this was matching. So let's say this wasn't a square bracket. If it was a parenthesis, what are we actually doing when we have a valid thing, right? I kept saying we're deleting these, right? So that leads you to know that we're popping from the stack. When we have a closing parenthesis, we don't even add this to the stack. If we know that the top of the stack is the opening version, that's like saying that we know this pair is valid, we can just remove it. So what you want to do when you see the top of the stack is actually correct, where stack -1 is equal to the open version, then all you're going to do is stack.pop. You're just going to remove that open parenthesis. Does this make sense to everyone? If anyone has any questions, just please stop me because we can go over a quick example and then we're going to talk about how we're going to code this. So let's go over 2 cases. I'll make them short. One, we're going to make like this. So we're going to give it just something basic like this. So let's say this is our input string. It's a square bracket, then some parentheses, then another square bracket. Let's try and do this like conceptually with all these points listed out, because these four like kind of conditions are things we want to understand now, so we're able to code it later on. So let's say we have our stack. Remember, our stack is literally just an array, right? So we start off with an empty array. I'm just gonna make it this big, but it doesn't matter. So we have an empty array. And the key idea here is we want to loop through every single character inside this string. So we're going to start and check what the first character is. First character is an open square bracket, right? So let's check our conditions. We have two, right? Either opening or close. So is this open or closed? This is open. What are we doing if it's open? We push this onto the stack. So what we're going to do is we're just going to push this open square bracket onto the stack. Does this make sense so far? Anyone have any questions? Okay. So we checked this from our string. Let's keep going. What is the next thing? We have another opening thing. It's an open parenthesis. So let's check, is this opening or closed? It's open. So we just push it onto the stack. So let me just do this. This is fine so far. Because remember that it doesn't matter how many open parentheses we have. As long as they're all going to get closed in the end, it's fine. We can have like a million open parentheses before we even see one closing parenthesis. So that's done. Let's keep going. What's next is we have this parenthesis right here. Let's check, is it open or closed? It's closed. So it's going to be one of these three options. Let's check, does the stack have items? If the stack doesn't have items, we return false. Let's check. Yes, the stack has items. There are items in it. There's two right here. So this is not true. This one, these two basically go hand in hand. This is kind of like an if or an else. So these two are pretty related. You can even see they're the exact same condition, except this is not equals and this is equals. So is this is the top of the stack, which remember, the top of the stack is the last item. So this is going to be at the top of our stack. Is it equal or not equal to the open version of the one we're looking at? Right now, we're looking at this one, right? We're looking at a closed parenthesis. This is an open parenthesis, so it does match. So it's going to lead to this condition. Since it does match, we actually just pop from the stack. So we can just remove this, right? And pretend it was never there. And we keep going. Anyone have any questions on what I just did? We just checked that this was valid. So you just pop from the stack because you know that this was fine and it was able to be closed. And then our last one is going to be a square bracket. Closing square bracket to be specific. So we go here, check, is there an item in the stack? Yes. So we keep going. Is it equal or not equal to its open version? This square bracket will be closed from this open bracket. So we just stack.pop. And then we're done with our string. We're done with our stack. At the very end of our for loop, or like looping through every single character, you notice that the stack is empty, right? This is once our for loop ends, we return true or false. We can't just return true, and I'll show you guys why we can't just return true after we're done iterating with everything. There's one condition where we return true, and that's if the stack is empty when we're done with this. Why is that? If the stack was empty, that means every single thing was able to be closed. It's kind of what I was saying in the brute force solution. If we can make this an empty string, then we know that it's fine and it was valid. So before I even finish this example, let me go over an example where this would be invalid. So if we do the same thing, and I have it like this, right? So let's say this is our input string. If we go through the same logic as the previous example I just did. So let me speed run this real quick. So we have two open parentheses, so we're going to add them to our stack. We have two closing parentheses, so they're going to pop the stack twice, right? And then we're left with one closing parenthesis. If we were left with one closing parenthesis, it would instantly return false here. But let's say we were met with an open parenthesis, right? If we're met with an open parenthesis, it just gets added to the stack and we're done looping, right? There was no issue with that because remember, when we add an opening parenthesis, we just push it on, right? So in example one, when we're done looping through the whole entire string, the stack was empty. But for example number two, the stack is not empty, right? We have one, and don't confuse these square brackets for like the characters. That's like, you know, the start and end of a list. We are left with one open parenthesis in this example. This is going to return false, but this is going to return true. So let me just mark that out so it's more clear. When the stack is empty, it's true. And if the stack is not empty, it's false. Because remember, if the stack is still holding items, that means there were characters that were never able to be closed. If the stack was empty, that means we iterated through the whole thing and we were able to close everything. You're never going to see a stack that has that, like, after looping through everything, you're not going to see a stack that only has a closing parenthesis because you would have returned false already from this condition. Does this make sense to everyone? We basically covered every point. And I'll show you how the hash map, the hash map isn't even technically necessary. It just makes things a lot cleaner if we're able to pair these together instead of having to do a bunch of if statements like if it's this closing parenthesis, check if it's this open one. Does that make sense to everyone? Okay. So yeah, just a quick overview of everything we just did, because this is definitely a lot to take in before we start coding this, is we want to loop through every single character in our input string and check two conditions. If it's an open parenthesis, then push it onto the stack. If it's a closing parenthesis, check two things. One, does the stack have items? And if the top of the stack is its corresponding open value. And then once you're done looping through that, that's all that's in the loop. You just do that for every single character. And then at the very end, check if the stack was empty, then it's true. If the stack wasn't empty, then it's false. Because if the stack wasn't empty, then not everything got closed. Does anyone have any questions before I start coding this now? And just checking the chat. Okay. So yeah, we'll get started with actually going through the solution. So it's gonna be up there, but let me just actually code it before I talk about it. So let me give me 1 second. Ooh. Okay, so let me pull up LeetCode and we're gonna go over coding this solution. So you guys should try and work along if you want to. And hopefully you can get it before I finish coding the whole thing, now that I've gone over all the logic. Because now that we've gone over all the logic, it's kind of just like writing it out in code. We basically went over every single condition that we have. And now we just need to put it in code. So I'll show you guys how to do this. So starting off, we need two things, which I'm going to start getting into the second thing more in detail because I didn't talk about it too much when I was going over the slides. But what do we need? We need our empty stack. This is our data structure that we're going to work with. We just need an empty stack. You can name this whatever you want. I'm just going to name it stack to make it easier. And remember that a stack, we just represent it through an array. So this literally is just an array. Anyone have any questions? Thank you. I did not see that. Thank you. Thank you. I don't even know how I didn't notice that. Okay, anyways. So yeah, we have our stack. And it's, again, in Python, it's just an array. So this looks like just a normal array because it is. That's what a stack is. And then the next thing we need is I'm going to start going into this more detail now. We want a dictionary or a hash map to kind of map these closed and open things together. Because if we don't, again, this isn't necessary, but it's a lot easier to kind of map them together rather than writing a bunch of if statements to check for every single parenthesis. Because remember that these three parentheses don't actually have differences from each other. It's not like if I see square brackets, I need to do something different than if I see curly braces, right? They're all the same. So we don't want to rewrite three different conditions just to do the same thing. So I'm going to make a hash map. I'm going to call it close to open, just to remind us that this is mapping all of the closing brackets to its open brackets forms. So dictionary, if you don't remember, is in curly braces. And we're actually going to put some key value pairs in here already. So we want to map every single closing parenthesis. So if I do this, we want to map it to its open value. So just like this. Oop. And you would do that for every single parenthesis. Does this make sense to everyone? Okay. So yeah, that's basically it. This is all our dictionary is doing. It's just a very easy way for us to map them together, just for kind of just clarity's sake. Because again, if we didn't do it like that, we would have to have an if statement of is our character a closing parenthesis? Is our character a closing curly brace? Is it a closing bracket? So this kind of will make it a lot easier to check kind of differentiate them. We're able to differentiate them in two ways. Now we have a way of checking if the character is specifically a closing bracket, because we can now say if the character is in our hash map. If we say if character is inside close to open, remember we check for existence of items in a hash map based on the keys. So that means that's just saying, is our character one of these three, one of the closing braces? And then now we also have an easy way to map our closing things to our opening things. And I'll kind of show you guys that more as we're going. So what were we doing? We were looping through every single character inside the array. So if we want to do that, let's just use a for loop. So I'm just going to remember, you can call this variable whatever you want, but I'm just going to name it for parenthesis. Actually, yeah, parentheses is fine, whatever. Actually, I'll call it bracket. Bracket's more general. So for a bracket in our container, which in this case, they just named the string S. So it's going to be for bracket in S. This now is going to loop through every single character. So now we're looping through every single character. What was the first thing we do? We have two different conditions. We check, is this an opening bracket or is this a closing bracket? We have an easy way to check if it's a closing bracket. Like I was just saying, if the character is inside our hash map, that means it is a closing bracket. So that's what I'm going to write. If the bracket is in close to open, again, what this means is basically another way to interpret this is our bracket a closing bracket? Because if it's in close to open, that means it's closed, a closing bracket. Let me just put some filler stuff here because I want to quickly cover what the second case was. Remember, if it was, how did I get down there? If it wasn't a closing bracket, oh my God, what's happening? Hold up. Okay. If it wasn't a closing bracket, that means it was an open bracket. So these were our two choices I was kind of talking about earlier. The first thing you want to do is check if the character is closing or opening. So let's work with opening first because opening is easier to work with. Do you guys remember what I said? What are we doing if to our stack if this is an open bracket? Does anyone remember? What's up? Exactly. Yeah. That's all you do. So remember, if this was an open bracket, all we're doing is just pushing to our stack. We're just going to append this. So what we do is just stack dot append, and we're going to just append our bracket. So just do this, and that's it. This is our open parentheses case covered. We're just saying anytime we see an opening bracket, we're going to add it to our stack. So we're getting close to done. We only have kind of this part left. Remember that this part was for closing braces. So I said if we have an opening brace, you just add it to our stack. If it was a closing brace, there were kind of 2/3 checks we look for. Remember, I was saying how two of them kind of go hand in hand. One of them was if the stack has items or not. If it doesn't have an item, then you return false. And then the other one was if the top of the stack is not equal to its opening version, then that's another way you would return false. So how can we kind of condense that into one condition? We want to kind of get the opposite. So we want to say when is the one condition that it is valid, because there are more conditions where it's not valid than is valid. And what I'm trying to say is I want to wrap as many things inside of an else as possible. So I want to get an if condition that can get us the one case where it is valid and we continue to keep going. And that was what? It was when the top of the stack was equal to the opening brace. So what does that look like? Remember, the top of the stack is stack -1. So if stack -1 was equal to the opening brace, how do I find what the opening brace is? That's what our hash map was for, or our dictionary. We can call close to open, and we have mappings for all the closing braces to all the opening braces. So remember, if I put in a closing brace here, it'll give me its corresponding opening brace. So does anyone know what I'm going to put inside this bracket? I'm going to put a specific word inside this bracket. Does anyone have any ideas of what I'm passing in? I'm going to be passing in the word bracket. And the reason is remember that bracket, these are just characters. Like this is, if we have a string like this, bracket is going to be one of these 6 characters. It's just an opening or a closing brace, right? So I'm saying if this bracket, so it could be one of these 3, is a closing bracket, check if its opening brace is there. Remember that the keys are the closing brackets. So this is like saying if closed to open, it's kind of like saying this. Does this exists in the hash map? And if so, return its opening version. So this would result in whatever it was mapped to. So remember, the closing brace maps to this opening brace. So it's basically saying, is the top of the stack equal to basically this? That's kind of how like the dictionary breaks it down. So does this make sense, everyone? Does anyone have any questions about that? About this syntax? Hopefully this makes sense to you guys. Okay. So we have this check, and this is saying it's valid. If the top of the stack is open or is equal to the opening version, what did I say we do? Well, remember, if it's equal to the opening version, that means that was a valid pairing, right? If it's a valid pairing, we can just pop from the stack because that's like getting rid of that pair. So what we're gonna do is stack dot pop. Okay, and then remember, there's gonna be an else. We had two kind of paths if we had a closing brace. One of them was popping from the stack if it's valid. Does anyone remember what the other option was? Like if this wasn't valid. So this means this else would catch things like if the top of the stack is a different brace. Does anyone remember what we do? So for this, we're gonna return false. Because remember, if the brace doesn't match up, then that just means the whole string was like invalid. Because this is just saying if the top of the stack is a different opening brace, then it just returns false.
Can you check for the other condition where the stack is empty?
Yes. Yeah, I was
Like, what are the-
exactly. Yeah, exactly. So hopefully that wasn't confusing you, but yeah, I was leaving that out on purpose because I was gonna be like, there's something missing. I'm glad you noticed it because like I know you're like paying attention. So yes, this code is actually incorrect so far because there's one more check we haven't looked for. Remember, I was saying earlier, not only are we checking if the top of the stack is equal to this, but we also need to check if the stack even exists in the first place. The reason for this is you can't check the top of the stack if it's empty or else that's an index error. But again, like if the stack was empty and we try to check if there is a open parenthesis to go with that curly brace, we know there's nothing to compare it to, and we know that we can instantly return false. So in this condition, we actually want to add this. We want to add if stack and this. So what this means is this condition can only pop if both the stack has an item and if the top of the stack was the open version. So that means this else is now catching any negation of this. So that means if this was not stack, that means if the stack was empty, you return false. If the top of the stack was a different opening brace, you return false. Does this make sense to everyone? Okay. So yeah, we kind of gone over all of our conditions now, right? If it was an opening brace, which is this else statement, then we append this bracket. If it was a closing brace, then we check, does the stack have an item? Then if it didn't have an item, it would instantly return false. If the stack did have an item, now it goes through the second check. The second check was, is the top of the stack its corresponding opening brace? If both of those were true, then return, or not return, but just pop from the stack. That's like clearing it. And then we have one more thing, right? I said one more thing. Once we are done iterating through our entire loop, there was one more check. We can't just return true here, right? Because returning true, like, yeah, we went through everything, but there's something else we need to do. Does anyone know how we have to change this line? We can add more lines if we want to, but there's one more check we have to do before we can just return true. Exactly. We need to check if the stack is empty. Because again, if the stack was not empty, that means there could be like a last opening brace or something. So for example, if like our input string was like this, if it was something like this part is going to get canceled out and popped, but then our stack is left with this open parenthesis. This obviously is not valid. There's nothing to close it with. So we only return true if not stack. That's just saying return true if not stack. That means return true if the stack is empty. Else, then we return false. And if this syntax doesn't make sense to you guys, there's other ways to write it. You could have done like the normal way, which is like if not stack. Oops. If not stack, return true. and then just like return false after. If that makes more sense to you, just feel free to do that. But yeah, like Python has like a one line thing for Booleans where you can just say like return this, if this, else this. It's just an easier way to put in one line instead of doing it like this. But yeah, I'm just gonna leave it like that. Does anyone have any questions on all of our code? That's basically the whole solution. So if I submit this, then it passes. And yeah, that's basically it. So going back to the slides, hopefully you guys were able to get that. But going back to the slides, let me just read through our solution now that we have it. So what we did was we made a dictionary to map everything together as well as our empty stack. And then we checked every single character in our string. There were two different options. One, if it's closed, one, if it's open. If it was closed, we need to check if both the stack exists and if the top of it is the open bracket. If it was, then pop it. If that was false, so that means if the stack was either empty or if the top of the stack was not the correct opening brace, you instantly return false because it can never be valid. If it was an open bracket, the only option you would do is just append it because again, like I've said before, there can be as many opening brackets as possible. And then remember the last thing, this is kind of like the opposite of what I just wrote. It's just written the other way. Return false if the stack, because that means if the stack has an item, just return false. If it wasn't, that means it was empty, you can return true. Does this make sense to everyone? Hopefully you guys all understand the solution. Okay. And then last question, I kind of already said what it was, but does anyone remember what the time and space complexity of this was? So time and space is going to be, both of them are going to be big O of n. The reason for time is because these are all O of 1 operations and checks. Checking something in a hash map is O of 1, which is why this was more efficient. Checking the top of a stack is O of 1. Popping is O of 1. Appending is O of 1, because remember, these are stacks. We're always doing it at the end. And we do it n times, where n is the number of characters in our string. The reason we have a big O of n memory is because our stack can hold almost basically the entire string. So that's taking up extra memory as well as our dictionary, but well, that's constant space. But our stack can hold up to basically the entire stack. So does this make sense to everyone? So yeah, that's basically our question for today. These are two more fun ones. Baseball game is definitely easier than this. Baseball game is like the most like bare bones stack question you can get. It's like you literally just kind of do what it says. So yeah, that's a very, very easy stack question. This min stack question is very fun. It's easy unless you see the last part, which is that every single function needs to be big O of 1, which is the hardest part, because how do you know what the minimum element is in the stack at all times? So that's kind of the harder part of min stack. That's why this is a medium and not an easy. In itself, it's easy, but because of this time complexity constraint, get min is actually way harder. And this is actually a question that you guys get asked in DSA. I know you're not in DSA. Are you in DSA or taking it? Yeah. So this was actually mentioned when you guys go over stacks. So this is definitely a fun one to look at. So yeah, that's basically, I definitely recommend checking these. This is definitely good practice because this one's pretty easy if you understand how to do this question. But yeah, anyone have any last questions? Okay, so yeah, basically it. Hope you guys all have a great day. Nope, no questions. Can we stop the screen sharing now?
Yeah, I think, yeah, that's the last slide. Okay,
All right, well, everyone, thanks for coming. Adrian, thank you as always. And well, enjoy your spring break. Don't do LeetCode. Don't go do anything but stare at a screen, trust me. But yeah, we'll have our next workshop the week after, and I believe instead of our normal time, will be an hour forward because we're doing a collab with Girls Who Code and possibly software engineering club. So that we'll keep you guys updated on that. But yeah, look out for that. That will be a little bit more of an upgrade. We'll probably have something for you guys to eat or drink, and more people. And yeah, so thank you as always for coming, everyone. And yeah, have a good rest of your week. Huh?
Next topic.
Oh, do you have something in mind that you'd like to see? You could let us know. Yeah, Adrian and I just talk about it every week. We could No?
don't know what we're gonna say.
I mean, stacks, probably queues after that.
Oh, they did just finish in pod two.
Yeah, I was just thinking about like maybe we should have just combined it, but we're in no rush. Might as well just take our time with one topic. No need to like slam them all together. That's like the beauty of well, this, in my opinion. So yeah, as always, if you guys like want to see something specific, never be shy to ask. Like please, like we're here for you guys. So yeah, all right. Kwong, I'm gonna sign off now, but thank you for joining. I hope you enjoyed.